Hey y'all, welcome to Ms. Clark's chemistry class. This lesson I'm going to talk about electron dot structures. They're very simple. This is going to be a very short lesson, so let's get started. Before we get started with electron dots, let's remember about valence electrons. Remember, valence electrons are in the outermost energy level, and in a previous lesson, I told you how to look at the periodic table and tell how many valence electrons those main group elements have. Now remember, those main groups, this is the tall groups. Tall group, tall group, tall group, tall group, tall group. You see, tall groups. Now, really and truly, these groups are numbered 1, 2, 3 through 12, 13, 14, 15, all the way to 18. But if we look at the periodic table, the main groups, we can just number all the way over. 1, 2, 3, 4, 5, 6, 7, 8. That tells us how many valence electrons. You can think about that as just counting over 1 through 8, just the tall groups, or you can think about not looking at this 1. 13 becomes 3, 14 becomes 4, so on and so forth. So if I'm looking at nitrogen right here, nitrogen has 5 valence electrons. Now, when we're doing electron dots, we're only showing valence electrons. It's just a very quick pictogram of an element and how many valence electrons it has. So let's practice. First, let me go back and renumber. We got 1, 2, 3, 4, 5, 6, 7, 8. So if we're looking at sodium here, let's find sodium on the periodic table. Here it is right here, and it's in group 1. So sodium has 1 valence electron. So we're just going to put one dot on sodium. Now, that dot could go anywhere. It could go on this side of sodium, or it could go on this side of sodium, or this side of sodium. It really doesn't matter. Now, I do think about each element as being in a square, like in a box frame. And so we're only going to draw dots on the 4 sides. Let's go to another one so we have more dots so you can see what I'm talking about. So here we have phosphorus. Let's find phosphorus on the periodic table. Here it is here. It's in group 15. It has 5 valence electrons. So if we are going to put those 5 dots, I'm going to go around the square. 1, 2. Now, I'm going opposite of each other because, let's remember, electrons are negative. Like charges repel. Electrons hate each other. So they're going to go opposites of each other. So 1, 2, 3, 4. Now I've used up my 4 sides. Once you have a dot on each of the 4 sides, then you can double up. We'll talk about why we can force electrons to double up in a future lesson when we're talking specifically about electrons. Make sure and be on the lookout for that. So we've got 4, and I'm going to double up. And it doesn't matter which side I doubled up. I could have put that 5th dot there. I could have put it here. I could have put it here. It really doesn't matter as long as you're going around the square, 1, 2, 3, 4, and then doubling up. Let's look at bromine. Bromine, if we find it on the periodic table, way over here in group 17. So it has 7 valence electrons. So again, we're going to go 1, 2, 3, 4, 5, 6, 7. Let's try another one. Let's go krypton. Kr, way over here in group 18, it has 8 valence electrons. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Let's do our last example, calcium. Calcium is in group 2 over here. It only needs 2 dots. So I'm going to put those opposite of each other. I could have put those here. It doesn't matter. Lewis dot structures. Now, I keep saying Lewis. I might have said Lewis before. I interchange those words. Electron dot structure, Lewis dot structure. Lewis is the scientist who first started putting dots around elements to show valence electrons, so he gets credit. I interchange them a lot. It's the same thing. Anyway, electron dot structures. They're pretty straightforward, pretty simple. Very important to chemistry. Make sure that you can identify any main group element's valence electron number. I will only ever ask you those tall main groups. I will never ask you how many valence electrons are from elements down here in the transition metals. This trend does not apply to those. This trend only applies to these main groups, these tall main groups. There's another word for these main groups. It's also called representative, because they represent the trends. Anyway, I hope that helps. Until next time, bye y'all.